Alright, so what I decided to do for my Chem Matters project was to focus on color film photography, and more specifically, the film Kodachrome. Now, Kodachrome is famous, or infamous, probably also, for its developing requirements and the technical aspects of the film itself, in that it has a very, very complicated developing process. So, moving right along. First, probably just a background on color itself. Now, as you probably all know, color is made up of light, of course, and light is made up of electromagnetic radiation on the visible spectrum, from about 700-ish nanometers to 350-ish between red and violet light. White light is made up of all frequencies of visible light, and it can be broken down into three main colors: red, green, and blue, on each end of the spectrum and in the middle. And also it can be broken down three other ways into yellow, magenta, and cyan colors. Each of these three, should we say, color formats, they're called additive and subtractive, can be used to create all colors of visible light. Red, green, and blue, or RGB, is the additive process, and CMY, or CMYK, as used in, say, color printers, is known as the subtractive process, and also is used to create colors. Also note that in the additive and subtractive processes, each color in each is exactly opposite to another color in the opposite process, such as yellow being opposite to blue, yellow being the subtractive and blue being the additive, cyan being opposite to red, and magenta being opposite to green. Now that we have a basic understanding of how light and color itself works, let's move on to what black and white photography is and how that works. So essentially, you have an ionic bond between a silver atom and a halogen atom. They can be bromine, fluorine, whatever. They all have different light sensitivity properties, but they all are light sensitive. When one of these silver bromide, say, crystals are struck by light, they then break down into silver and bromine. In the early days of photography, originally they had very, very long exposure times, so that once the exposure was finished, there was already a visible picture on the film, or in that time they used glass plates. What they figured out was that you could take a much shorter exposure picture and treat it with a chemical. One of the early ones was hydroquinone, which is still somewhat in use today, as a reducer to reduce it further from silver bromide into silver and bromine, thus reducing the exposure time. Another aspect of black and white photography that we have to know about is the idea of film speed, or how quickly the film exposes to light. Certain films are either more sensitive or less sensitive, and it uses a scaled rating system, the ISO system, where, say, a 100 speed film is half the speed of a 200 speed film, and a 400 speed film is twice as fast as a 200 speed film, and vice versa. This is important because silver halides in their basic form, such as silver bromide, are mostly sensitive to violet and ultraviolet light. Towards the later half of the 19th century, they started to discover that if you treated the silver halides with certain dyes, you could extend the sensitivity of these into the lower regions of the visible spectrum, such as the green and eventually the red areas. This was necessary so that they could create what's called a panchromatic emulsion, where it's sensitive to all frequencies of light. They need this for color, otherwise you wouldn't be able to represent all the colors of the visible spectrum. Now, some of the very early attempts at creating color were often simply where 3 black and white exposures were taken, on a panchromatic emulsion, each through a different colored filter, normally using an additive process, so a red filter, a green filter, and a blue filter. And then during development, they then were put in register with each other so that they lined up perfectly and had filters on top of each layer. This would create a color transparency using the 3 black and white films. Another quick thing to note is that when black and white film is developed, or any film really, originally it creates a negative, whereas where light strikes the film it creates a dark spot, and where light does not strike the film it creates a light spot. When the negative, it's called, is printed, this is then reversed, where the light colors, or the light spots on the original image become the light spots on the print, and vice versa. Some other examples of the early color processes include the Kodachrome from France, where they took dyed potato starch grains, mixed them all together, coated a panchromatic emulsion onto a glass plate or later film, and then coated this potato starch solution on the top of it. What this did was that it created a mosaic of colored filters over the silver halide grains, so that when it was exposed, it only exposed the silver halide grains to the specific color of that filter. The plate or film was then reversal processed so that it would create a color transparency. Another process was known as the Dufay color process, which used essentially the same idea as the Kodachrome, but instead of using a mosaic of potato starch grains, it used printed dyes upon the glass plate or upon the film, where it would print a red line, a green line, and a blue line, all in different directions. One of the first steps towards the modernization, I guess you could call it, of color film and color film development was the original 2-color movies, and the discovery of color couplers. What they discovered sometime in the early 1900s was that during development, during the positive reversal of reversal development, was that with the developer it would become oxidized wherever it was reducing the exposed silver halide into silver and the halide. When it became oxidized, they realized that if you mixed certain chemicals with the developer, they would hook onto that oxidized developer and create a dye. The way that this was utilized with 2-color movies was that they would take a specialized camera that ran 2 film strips at the same time, each exposing through a different colored filter, say a red and a green filter, and then during development they would process each during the reversal process in a separate chemical bath in order to create a different colored dye in each of them. After development, they were then bound together into one film strip and be able to run through a projector. This was also used in Technicolor. You've probably heard of it. But that Technicolor was essentially a 3-color process using the same technology as where they would bind the 3 strips of film together, and where it used a specialist camera, except using 3 film strips at the same time. So now there were these 2 musicians, Leopold Manes and Leopold Godowsky Jr. They went to go see a 2-color movie. It happened to be one called Our Navy, sometime in the early 1920s, or late 19s probably, and they were very dissatisfied with the color rendition of it. It was just very, very poor color rendition. So they went to their local library and began to look up color photography and photography in general. They started a little lab. I believe they were in New York at the time, and one of them, I believe it was Manes, happened to stumble upon an investor at Kuhn, Loeb and Company in 1922. He struck up a conversation with somebody who worked there and began to talk about his and Godowsky's color photography experiments. The investing firm was interested enough that they would provide small funding for them and set up a small lab. So for a while they were working there. About 8 years, actually. Took a while. By then, Eastman Kodak got wind of their experiments with color and decided to fund them themselves. Since at the time Kodak only had a 2-color process, they wanted Manis and Godowsky to create a 3-color process. This 3-color process later became known as the integral tri-pack film, whereas there are 3 different layers of the film with 3 different emulsions sensitive to 3 different areas of light. These 3 separate layers would be then a red sensitive layer, which would in development create a cyan dye, a blue sensitive layer, which would in development create a yellow dye, and a green sensitive layer, which would in development create a magenta dye. Now remember, the way that the 2-color movies worked was that they would run 2 strips of film through the camera at the same time. In order to do this and get 3 separate colored images with only a single strip of film, they would either have had to A, incorporate the color couplers but create the dyes into the film at manufacture so that it would create all 3 colors in one development, or they would have to incorporate the color couplers into the development chemicals and do 3 separate development stages for each of the 3 layers of the film. The problem then arose that if they incorporated the colors into the layers of the film, the dyes would then seep into the other layers and create a very muddy image, I guess you could say, or where a smeared image would be a better term, where all the colors were moved around slightly. Also, one of my sources was many of the patents that Kodak held for the Kodachrome film, and some of the compounds that created the couplers I just put on here. Phenols and naphthals created a cyan dye. Pyrazolones, cyanoacyl, and magenta methylene with 2 carbonyl, pyrazolones and cyanoacetyl created magenta dyes, and methylene with 2 carbonyl groups created yellow dyes. There are numerous patents that utilize different chemicals that use these in them. So on to the layering of the film itself. The way that they did this was that on the very top layer they would have an ultraviolet light filter so that the silver halides would not be exposed to ultraviolet light, because remember they're sensitive to violet and ultraviolet naturally. Then they would have a blue sensitive layer on the very top, then a green sensitive, also called an orthochromatic layer, and in between the two, the blue and the green layer, they would have a yellow filter. Now remember that the blue sensitive emulsion creates a yellow image. Filtering out the yellow light, or filtering out all light except yellow, essentially blocks any light above blue light, meaning green and red light still pass through. So then you had the green layer, and then beneath that, finally, the red layer. And beneath that you had the plastic base, and on the very back, on the bottom side of the film, you had what's called an anti-halation backing. That was used to essentially block any light from reflecting off the back of the film back into it, to stop any double images, or ghost images, I guess you could say, from being created. Now, at exposure, it creates 3 separate images in the 3 separate layers. Once it's taken in for development, first of all, the anti-halation backing is removed. Second, it's just a standard development to create a negative image in all 3 layers. Then the first reversal process is done for the red layer in the bottom. So through the back of the film, they would expose it to red light and put it in a developing bath, much the same as the first one, although this one, when it reduces the silver halide, it creates, or it oxidizes, and then creates the cyan dye in the red sensitive layer. The reason that red was first was because none of the other two layers were sensitive to red light, because essentially the more you sensitize it, the lower in frequency of light it's sensitive to, whereas green and blue are both higher in frequency. Next then was the blue layer on the top. They would expose it to blue light, and it would not affect the green layer because remember the yellow filter is in there. Then they would develop it in the same bath as the red sensitive layer, albeit with a yellow coupler in it, so it would form a yellow dye on the top. And also I should note that the yellow filter in there was made up of a special kind of silver halide that it's called Carey Lee silver. It was it's essentially just a yellow particle. I don't remember offhand what exactly the chemical properties of it was, but it essentially filters out yellow light, and it's able to be removed in the development process. Now for the final green sensitive layer, they couldn't expose it to light because on either side of it there was a filter of some kind. On the top there was a yellow, and on the bottom there was a blue. So what they did, in order to expose the remaining silver halides and complete the reversal process, was they used a chemical fogger. Fogging is essentially exposing it to light to re-expose the unexposed halides and create a positive image. A chemical fogger then completely reduces all the silver halides into silver and a halide. So they had this traditional developer and the final magenta dye coupler mixed into a solution, which they developed it in. So at this point, there's a yellow filter on the top, or a yellow layer with yellow dye, the yellow filter, magenta dye, and blue dye on the bottom. And also note that in each of the layers it is completely exposed. There is no more silver halide left. All that is left within the film is silver atoms. Next, in order to remove these remaining silver atoms, they treat it with what is called a bleach. This isn't the same kind of bleach like chlorine bleach, Clorox bleach, whatever, but it essentially removes the silver from the emulsion. It's suspended in gelatin, and it removes it out of the film so that you're finally left with 3 dye images. After the bleach, it's then treated with a fixer. A fixer essentially removes any remaining silver halides that might have gotten left in there, so that there is nothing left in the film besides gelatin and the dye images. And also finally, the film is washed and dried. A partially startling fact is that Kodachrome was actually released to the public in 1935. Most of you probably assume that it would have gotten accepted by the market right away because it was a new fancy color film. But actually, black and white remained very popular up until probably the late 1960s, mostly due to the fact that it was just very expensive. The fact for this expense was that the development process, as I just went over, was very, very complicated and relatively hard to do. And all over the world there were less than 10 labs that could develop it. Because of this and its low unpopularity, it was eventually reduced by films that did have the color couplers present in the film itself, so that essentially for these films you could develop it in two processes, once for the negative development and once for the reversal development, greatly simplifying the process. Also, what emerged after Kodachrome was color negative film, which is essentially the same thing as E6 film, which I just said it has two development parts, but instead of creating a positive transparency, it creates a negative transparency. This is used mostly for printing onto color paper. Another thing that came about was Ilfochrome. This was made by the company Ilford. Essentially, it's a color printing process where when light strikes it's a paper. When light strikes the paper, it destroys dyes rather than creating them. And then in development, a color image is revealed. And then also, obviously, digital photography. So for my collaboration on this project, after I researched quite a bit and looked at the patents quite a bit, was I went on apug.org, which is Analog Photography Users Group, and I posted a thread just asking a couple of questions that I hadn't found an answer to in my research. One of them was about the yellow filter, and another one was about the anti-halation backing. And one of the more well-known users on this forum, known as the photo engineer, actually, he's a retired employee from Kodak. He replied to me, clarifying that the anti-halation layer was Remjet. It's, I believe, a brand name, and how it's removed in the process, and explained to me what the yellow filter was. That it was Kerry Lee silver, which I explained earlier, or just simply a yellow dye that gets washed out during development. In addition to the photo engineer, I had a number of other responses, and over the years since Kodachrome has been discontinued by Kodak, he's been, I guess I could say, bothered quite a bit by people on the forums as to how its development works, and I guess I'm speaking for him, is kind of sick of people asking about it. But someone else, right now I can't, his name was Flavio81, was nice enough to look through many of the threads on Kodachrome and basically quote parts of it and compile it all into one large post and put it on the thread that I created. Also, by the way, if you're on that thread and watching this, thanks for the help. It was really useful. And lastly, the last thing I want to talk about is what I call Kodachrome Resurrection, or the home development of Kodachrome, since commercial processing is no longer available. There's a company, their name is Rockland Colloid. They specialize in, odd photography materials, I guess you could say. They sell liquid emulsions that you can use, and another thing that they sell is this product called Polytoner. Essentially what this is a kit containing all three color couplers and the developer for it. So in the future I plan to experiment with this and some old Kodachrome film stock in order to attempt to recreate the color process using the three different color couplers to create the three different dyes within Kodachrome and try to develop it. To date, I believe there's 2 people that I know of that have been partially successful in trying to do this, and they both tried it using either the original chemical formulas for the color couplers, or they used the color couplers found in more modern films such as E6 films. So, if you're in my science class, I guess I'll keep you posted on that, and if you're on APUG, I guess I will keep you posted on that as well. So for now, thanks.